10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Left off detected.
And we're off the pad for our 8th Electron launch. Soon we'll be approaching the point of the flight where the forces against the rocket are at their peak, otherwise known as max Q, or maximum aerodynamic pressure. Let's listen in for that call.
HP battery discharge nominal.
Vehicle is supersonic. Approaching maximum dynamic pressure. Passed through max Q.
Brutus has entered flight mode.
There you have it. Electron has gone supersonic and has made its way through max Q. We'll now tick through a number of milestones on the way to orbit.
Guidance is nominal, 50 seconds remaining.
AOS Chatham Station.
Stage 1 propulsion remains nominal. Stand by for MECO in approximately 30 seconds.
Soon the 9 Rutherford engines on Electron's first stage will shut off ahead of its separation from the rest of the rocket. Once Stage 1 and Stage 2 have separated, the final vacuum-optimized Rutherford engine on Electron's second stage will come to life and propel Electron the rest of the way to orbit.
Stage 1 MECO confirmed.
Stage separation successful.
Stage 2 ignition. Propulsion is nominal.
And there it is. Main engine cutoff has been confirmed, and Electron's first and second stages have successfully separated. For the payload to be deployed from the kick stage, first the protective fairing needs to open up and fall away. Things are looking good, and propulsion is nominal as we approach fairing separation.
Fairing jettisons succeeded.
The fairing is separated, clearing the way for payload deployment, coming up in approximately...
Engine shut down.
Good transfer orbit achieved.
Works to deploy payloads to orbit. We use Stage 2 to take the payload to an elliptical parking orbit, as shown here, before the kick stage separates from Electron's second stage. By leaving the second stage in this highly elliptical orbit, it experiences a high amount of atmospheric drag, and as a result, the stage is dragged back into the Earth's atmosphere to be burned up in just a matter of weeks. Meanwhile, the kick stage lights its 3D printed Curie engine and circularizes this orbit before deploying the payload. The kick stage is equipped with a cold gas reaction control system, which means we can accurately point the kick stage and deploy payloads to incredibly precise orbits, even when we're launching multiple satellites at once. Once the kick stage has deployed the payload, the Curie engine is capable of reigniting and performing a de-orbit maneuver to burn itself up, leaving nothing behind in orbit but our customer satellites. So with that, I want to thank our mission partners.